Hello. So in this tutorial, I will explain about Z-score and how to use Z-table. Okay. So as we have seen in the previous tutorial, Z-score is a measure in terms of standard deviations from the mean, and mainly it is used to convert normal distribution to standard normal distribution. So let us understand this in more detail. Suppose you have a curve, okay, Gaussian curve as that is given over here. See, we have the Gaussian curve over here. In the regular Gaussian curve, you have the mean followed by one standard deviation, two standard deviation, three standard deviation. This standard deviation will be as per the data in the Gaussian curve, right? So if the mean is 100, the standard deviation can be 20. So then this will be 120 or so. Okay, so that is how usually the Gaussian curve is distributed. You have the mean, then from mean, standard deviation, two standard deviation, standard deviation, etc. Okay, now in order to convert this Gaussian curve to standard normal distribution, what can be done is we'll consider that mean is equal to 0. Okay, and if mean is equal to 0, then first standard deviation will be 1 st, second standard deviation 2 st, third standard deviation will be 3. So mean is 0, from mean one distance from it is first standard deviation, then this is second standard deviation, this is third standard deviation, that is 1 2 3. It will be like that. Okay, and here it will be minus 1 minus 2 minus 3. So in this standard normal distribution, what happens is your mean is 0 and your standard deviation is 1. Okay, that is why it is 1 2 3. Here minus 1 minus 2 minus 3. Okay, now in order to convert a Gaussian curve to standard normal distribution like this, first you have to find the Z-score. Okay, Z-score will the value of, if in the normal graph, X is the point, X is a particular point, then its corresponding Z-score will be the point in the normal standard deviation. Okay, so in order to calculate it, it will be, if you see over here, the set score of a point x is given as x minus mu by x minus the population mean minus the by the population standard deviation. This is how you calculate the z score of a point. So you have a corresponding point x on the mean standard Gaussian curve, then zx will be the point in the standard normal distribution. I hope it is clear now. So in this manner, we'll also be able to understand how far the particular point is from the mean. So suppose you have a point over here. Okay, you have a point over here, say here. Its corresponding set score will be somewhere between 0 and 1. So we'll come to know, okay, it is 0.7 5 standard deviation far from the mean. And here, suppose you have a point over here, its z score will be somewhat between 1 and 2. It will be 2.4 or something. Okay, so you can say the point is 2.4 standard deviations from the mean. Okay, so z score basically, since the mean is 0 and standard deviation is 1, z score basically gives the distance of a point from the mean. Okay, we can understand how many standard deviation a particular point is from the mean. Okay, now this is the formula. So let us see one example over here. Scores on a particular test are normally distributed. So this is, we are speaking about normally distributed, it's giving. So here we are speaking about Gaussian curve with a standard deviation of 4. Standard deviation of 4 means standard deviation, this is population, so sigma equal to 4, and a mean of 30. So again, this is population data, so it will be mu equal to 30. Okay, how many SDs is a score of 40? So what it is asking, it is asking us to find if there is, if the mean is 30 and standard deviation is 4, how many SDs will be a score of 40? So if we draw the Gaussian curve like this, here somewhere we have the mean 30, and standard deviation is 4, means this is 34, this will be 38, this will be 42, like that. Okay, now we have 40 somewhere. We are here, we need to find about 40. Okay, it is asking how many standard deviation is this 40 from the mean. Okay, so if you want to find this, you have to find what? The set score. That is what we have applied over here. Okay, so what is the formula of z? Z equal to x is 40, right? 40 minus mean. Okay, mean is, we know that it is 30, by standard deviation, that is 4. So when you calculate, you get it as 2.5. Okay, so we can say that the score 40 is 2.5 is this away from the mean. So in another way, when we draw, the graph will become somewhat like, our mean will be 0, this is standard deviation 1, this is standard deviation 2, so somewhere here 2.5. Okay, so whatever interrupts here, here lies our score that we are interested of. So it is 2.5 standard deviations away from the mean. That is how his set score helps us in finding the distance from the mean. Okay, now, let us see how we can calculate the set score using Python code. This was a normal formula. Yes, we applied the formula using the code, but there will be functions which help us in calculating set score. That is what we are going to see over here. Okay, so you have to, what you have to do, you have to import scipy.stats as stats. Then what you have to do? Then you have to so if you have an array, this is the array that I am having. So in order to find the set scores or off of it, what you have to do is stats dot set score of data. If you give, you will get the set score of all the elements inside this. So if you will come to know, this sits is minus 1.3 standard deviation away from the mean. This is minus 1.19 standard deviation away from the mean, like that. And here 0 0, so this is the mean over here. Okay, so like this you can calculate the set score using Python code. Now let us see what is set table. Okay, so the area under the whole normal distribution curve is 1 or 100%. Okay, right? So area, if you ask the area under this curve, it will be 100%. Okay, or we can say it is 1. Okay, it is complete thing, we can say it is 1. The entire area, the total area is 1. The set table helps by telling us what percentage is under the curve at any particular point. Okay, suppose I am having a x over here. Okay, so now how many percentage of value is below x? Okay, how many percentage of value below x you can know from the set table entry for the set score of this x. Okay, so the steps is, you have to first, you have to find the set score. First you have to find the set score, you have to find set score, you have to find. Then you have to go and check the set table and find the corresponding entry. That will give you the area. Area means how it will give, what it will give, it will give how much percentage of entries is below this particular value. Okay, that is what the set table entry gives you. Okay, now there are many set table entries. Okay, so in order to make our life easy, there are two set means we here we'll look into two set tables: positive set table and negative set table. There are other versions of set table, which is left set table and right set table. So it is the easiest one is positive set table and negative set table. So we will understand this. Okay, what is it? To know the area, so if you have a value, so this is the mean. Okay, this will be the mean all the time, right, in the middle. Okay, to know the area to the left. Okay, so if you know to the area to the left of the set table, then you have to go for positive set table, or basically when z is positive. Okay, when z is positive, you have to look into the positive set table, and when the z is negative, you have to look into the negative set table. Okay, another thing is, set table always give the area towards the left. Okay, always it gives the areas towards the left. So once you have this area, it will be very easy to find this area, right? It will be 1 minus this area, right? So that is how you can find the other areas. Okay, now let us see some example. So before it, I will open the set table and show. So if you see, first we have the negative set table. That is, it gives the value of all the set which is having a negative value, right? So you look into it. If you see, all the negative values are given over here, and the corresponding areas, corresponding set table entry is given over here. Okay. Now we have the positive set table also. If you see over here, see, this is positive set table. So if you look into it, you will get all the areas which is towards the right of the mean. Okay. Now let us see this with some examples. The question is, what is the probability of anyone scoring less than 40? Mean 30. Mean is 30. Okay. Mean is 30 and standard deviation is 4. So this is the same question that we have seen earlier. Mean 30, standard deviation 4, and the value we are interested of is of 40, right? We saw this thing earlier. We saw that the set score of 40 is 2.5, right? We calculated it earlier. Now, what is the probability of anyone scoring less than 40? So we know that the entire area is 100%, right? Entire area is 100%. So anyone scoring, so how many percentage of value is less than 40? That is what we are interested in finding out. Okay. So what we have to do, we have to find this entire area. If we find this entire area, we will come to know how many percentage of value is less than this value. Okay. So what we will do is corresponding to the score 2.5. Okay, so we know that the set score is 40 or 40 is 2.5, right? So then we have to check into positive set table. Okay, so let us go and check into positive set table. So here we have the positive set table over here. So let's close this also. So 2.5, it is just 2.5, right? So what you will have to do is, see, 2.5 and 0, it is 2.50. 2.5 means 2.50. So this is the corresponding value under it, that is 0.99379. Okay, 0.99379. So point 99379. Okay, so this much is below 40. So it means that into 100, if you do, we get that 99.379 percentage is below. Okay, that many values is below 40. So I'll just show it over here. Yeah, so 99.379 percentage of values is below 40. See, 99.38 is scored less than 40. Okay, this is how you find out. Now let us see the next question. What is the probability of anyone scoring more than 40? Okay, anyone scoring more than 40 means we are interested in this area, right? So anyone scoring more than 40, we are interested in this area. So we know that from the left left of the z table, the value is point, the area is 0.99379 or something, right? 379 or something. So what will be this thing? It will be 1 minus that value, right? So 1 minus that value, I got it as 0.00625. So 0.63 percentage of people only scored above 40 in this case. Okay, so that it is how all about, are you understanding how to read the set table? Once you know how to read the set table, it will be very easy. You should understand which area we are interested in. Okay, which area of the score, say this thing we are interested in. Okay, now what is the probability of anyone scoring between 30 and 40? So we want to get this value, right? This value we are interested in. Mean is 30, standard deviation 4. Okay, so for 30 we know that it will be the mean, it will be 50 percentage of value will be lying below 30. That we know that already, right? Otherwise also, if you convert 30, its z score will be 0, right? Since we are considering the mean will become 0, right? And if you check the set table over here, 0, it is zero point 0.5. Okay, zero point 0.5 means it is 50 percentage. Say 0, 0, it is zero point 0.5, it is 50 percentage, right? Yeah. So we know that the area below 30 is, this is zero point 0.5. Okay, and the area below 40 is 0.99 something, that we already knew. So this and this, so the total area is 0.99 something, and this area is 0.50. So in order to get the in between area, what we have to do, in order to get this area, what we'll have to do, we'll have to subtract the larger area from the smaller area, right? So that is what we are doing here, and we got it as 0.49. So the probability of anyone scoring between 30 and 40 is 49.375 percentage. Okay. So with the example, you would have understand how to read the set table and how you will be getting the value. I'll show multiple cases. Okay, how to read those. Now, if you have a point over here, how to get this area? So it is very clear. You have to look into the positive set table. It will give you the area towards the left of it, right? It will give you the area towards the left of it. It is very clear for us, right? Now, if we want to get this area, okay, so from the, we know that from the set table we can get this area, right? From positive set table we can get this area, and once we have this area, how can we find this area? It is just we have to do 1 minus this area. Okay, so you will be getting this area. Okay, now how can you get the this area? Okay, that is the area towards left of this negative z. Okay, so here, since you have the mean, the z that is lying over here will be negative. So what you will have to do, you will have to look into negative z table, and then you will get the area towards the left of that that set. Okay, so here only difference is that you have to look into negative set table. Okay, now again, if you come to the next case, that is this. Okay, so that is, this is again towards the right. Z table gives us the area towards the left, right? So, and since the z is negative over here, you look for the negative value on the negative Z table. You get this area, and once you have this area, it is very difficult. It is very easy to get this area. It is 1 minus this area. Okay, if you do 1 minus this area, you will be getting this entire area. Okay, now if you want to get some area between two things, okay, this we have seen earlier, z1 and z2, what you will find, you will first find the area of z2, then you will find the area of z1, then you will subtract both. So since this area is more, so you will subtract the area you got from z2 with the area you got from z1, you subtract both, you will get the intermediate area over here. Now suppose if both the z's are here, then again, in order to get it, again, what you will have to do is you will have to get this area. Okay, this z2 you will have to get, then the area of z1 you will have to get, you will have to use the negative set table. Then what you will have to do is you will have to subtract this entire area from the area of z2. Okay, then you will get this intermediate area. Now coming to, let us see another question over here. So, what is given? Annual salaries for a large company are approximately normally distributed. So, normal distribution means this is again a Gaussian distribution, right? And with a mean of 50,000. With a mean of 50,000 means, so you have mu equal to 50,000, right? So, the mu is 50,000 and standard deviation of 20,000. So, sigma, okay, or population standard deviation is 20,000. Okay, now what percentage of company workers may be under 40,000? So we'll just draw the graph and see. So this is the graph. So mu is 50,000. Okay, standard US. So this will be some 70, this will be 90, this will be 30. Okay. Now what we need, what percentage of company workers may under 40,000? So 40,000 will lie somewhere between here. Okay. So the set score will be coming somewhere here. So, okay. Now what we need to find, we need, what it is asking, what percentage of may be under 40. So we need to find this area, right? So what we'll have to do, we'll have to find the set score corresponding to 40,000, right? And since it is to the left side of the mean, that is, it will be a negative set score, right? Negative set score. So you will have to look up the negative set table, and then you will be getting the area towards this. That means that much of company workers will be under 40,000. Okay, so that is what is being done over here. So we have found the set score is minus zero point 0.5. So this is minus zero point 0.5. Then we look into the corresponding value on the table. Okay, so let us see. Okay, let us take minus zero point 0.5. Where is minus zero point 0.5? No, I am looking into positive set table. Let me take negative set table. Huh. Now minus zero point 0.5. Okay, so minus zero point 0.5 is this thing, right? Minus 0.30854, right? So 0.30854. See, it is 30.85. Okay, 30.85 percentage. Okay, so this is got from the positive set table, considering ignoring the negative sign. That is why we had to subtract it with 1. But again, the final answer will be 30.85 percentage. Okay, now let us see how we can write the Python code to find it. So how to get the value using value from table using the Python code. Okay, now we are manually checking the table, right? How we can value get the value from the using Python code. Okay, so we have a function, stats dot, what it will do is it will calculate the what it will do is it will create a standard normal distribution. Okay, and here LOC or log means mean and scale means standard deviation. So we are passing 50,000 and the standard deviation at 26, and dot cdf. Okay, this function will give you the set table value or the area under it. Okay, dot cdf for 40,000 you gave, then again you got it as 30.85 percentage. Okay, so if you have a standard deviation in this manner, that is location 50,000 and scale standard deviation, then you use the cdf function, you will get the area under the set curve. Okay, now let us try to get all the areas using the Python code. Okay, we earlier we were getting everything using manually. Now here we are using the Python code to get the value. So initially we were finding the area below 40, right? So dot cdf 40, and we got the area. So this is what we calculated manually also. Okay, when we calculated manually also, that is what we got. If you see over here, see, when we calculated manually, okay, this is towards the right. When we calculated manually of also, this is what we got. Okay, same thing we are getting when we use the Python function for it. Okay, CDF function will return us the same thing. Okay, so CDF function has returned us the same thing. Now, what is the probability of anything scoring above 40? Above 40, so what you will get? You will get 1 minus of that thing, then you will get the proper thing. Okay, either you can use 1 minus the CDF of 40, or what you can do is you can use the SF function over here. SF function, what it will do, it will automatically calculate 1 minus and it will return you the area towards the right of the point. Okay, that is also you can use. Either you can use the CDF function or you can use the SF function. Okay, now in order to calculate the area between this, you just have to pass 30 and 40 over here. Okay, So what it will do, it will give the area below 30, okay, like this, and area below 40. So it will return you a array or list of the areas. Then you just subtract the both the areas, then you will get the area between the both the values. Okay, so that is how we can use set table manually and also through code to calculate the area below a particular value. Okay, so today we have seen what is set score. Set score is basically a measure which gives you an understanding of how far a point is from the mean. So it is also used in standardization. Standardization of a normal curve is when you are taking the mean as 0 and the standard deviation as 1. So in that curve, you have to find the set score of each and every value so that you will be able to plot the standard normal curve. So once you have the set score, if you get the set table entry particular to that set table, you will be getting the area below it. Always the set table gives you the area towards the left of the table, left of the set score. There is positive set table which gives you the area towards the left of the positive set value, and there is negative set table which gives you the area towards the left of the negative set value. Okay, and in case of Python, you can use CDF function to get the area below a particular value. You can use SF function to get the area towards the right of a particular value. That's all for today. So if you like this video, do like and subscribe to the channel for more such videos. Thank you all.